In our next session, we will take a look at WSA deployment modes. I'm going to discuss the different proxy modes, and we will also take a look at what is known as a layer 4 traffic monitor, an optional service that can be potentially enabled in addition to the proxy function. There are two ways of deploying WSA, known as proxy modes. We can go for explicit forward mode, or we can use the transparent redirection. This first option, explicit forwarding, as we will see in just a moment, is all about sending packets directly to the WSA, where with a transparent configuration, the goal is going to be to somehow fetch the packets from the network, intercept the client web communication from the network, and then send it to the WSA. So in the second case, our clients will not be sending packets to the proxy, and they will be sending packets to the final destination. And we also have this optional type of config, which is known as layer 4 traffic monitor. It's deemed as one of the deployment settings because it requires special interfaces, special ports to be enabled on the proxy. And this is going to be a T1, possibly along with a T2 port, which are both acting as promiscuous ports. So if you go for T1, it means that you want to use just one interface for inbound and outbound communication, where if you go for both ports, one of them is going to be used for inbound and the other one for outbound data. Since, as I just mentioned, these interfaces are acting as promiscuous ports, we will have to somehow deliver traffic from the network to T1 and possibly also T2. This can be done using a span or remote span, like when you configure switches to copy communication from one VLAN or maybe multiple VLANs, and then send those packets to the interfaces, switch ports connected to T1/T2. You can plug those interfaces to a hub and then attach this hub to the network. And option number 3 is going to be to go for a network tap. Okay, now the reason why this type of deployment is not commonly used is that L4TM is acting more of like an IDS system, which is, I would say, pretty limited in terms of functionality. L4TM is all about getting packets from the network to analyze them, looking for signs of malware. Well, malware inspection can be also done by the proxy, but the thing is that the proxy is only looking for certain ports, like 80, maybe 443 when you do the decryption, 8080, whatever port number you configure for the proxy, it is going to be looking at those packets. Versus with the L4TM, what is going to change is that we will be potentially looking at some other ports as well. Now, technically, you can configure this feature to look at every TCP port. So any number, which means that you might inspect other communication like DNS, or maybe Telnet, anything else that runs on top of TCP looking for malware, comparing the content of the packet to the signatures found in the WSA sensor database. And now the only thing that you can do when a malware is detected is going to be to log the connection with the monitor setting, or you could optionally block, try to terminate the session by sending a spoofed reset packet. So assuming that you're running some sort of a IDS IPS in addition to WSA, you probably don't want to use L4TM. This is more of like an extension to the regular proxy function, not something that people actually use a lot in production. But just in case you have this option, it is pretty easy to deploy it. You just enable the port and then send packets to the WSA. Now, in terms of the actual proxy modes, there are going to be two of them. As I said, we have explicit forward and we've got transparent redirection. With explicit forwarding, the goal is going to be to send web communication from the client directly to the WSA, which means that we will have to either reconfigure the client's browser settings by pointing to the IP address of the WSA. Maybe let's quickly take a look at this with Firefox. So depending on what type of browser you use, the actual option might look differently. But in case of Firefox, I believe this is going to be under Now let's try content, or maybe security. Not security. How about advanced? Advanced, let's go to network, and then connection settings. So this is where I can specify IP address of the WSA. Like in our case, it would be 192.168.123.50, the P1 interface of the proxy. And then I would also have to tell it what port they want to use for communication. In most cases, it is going to be simply port 80. So this is option number 1. Now, I will not be configuring those settings. We will use transparent redirection. But just in case if you want to use this mode, it is also possible to use proxy auto configuration file to push the information about the proxy IP address for a certain prefixes, because this is actually what a proxy auto configuration pack file is supposed to tell the browser. The pack file is just a JavaScript that consists of possibly multiple entries, where each of the entries tells what IP address range it applies to and what's the IP address of the proxy that should handle connections destined to those addresses. So this way you can be pretty selective with what websites should go for the proxy versus what shouldn't. In most cases, you will send all communication, maybe let's say non-internal communication, to the proxy. And the pack file itself can be distributed using several ways. You can either push it in your Windows group policy as part of the policy config, or maybe you can deliver the information about the file using DNS or DHCP. So this is more of like an automated method of telling the client's browser, what WSA to use. So these two options, this is how we will force the client's browser to send packets to the proxy instead of to the final destination. And now this has some important implications. In this particular case, and notice that since the browser is going to be pushing all web packets, every single web packet to the WSA, the DNS name resolution is technically not needed on the clients. Because anytime I put something into the browser URL, the device is going to automatically build a web packet which is going to be sourced of the client. Like C1, let's say that C1 is my web client. And the packet is going to be destined to the WSA. No matter if the packet is sent to Google, or let's say Cisco, or ndtrainings.com, this is how the packet is going to look at layer 3. The source and destination is going to be kind of like fixed. We don't need to make any type of name resolution because the goal is to send all packets to the WSA. Now, the second implication here is that the client device doesn't even have to be configured with a default route to access web content, to access web pages. So the only IP route that the client needs to have is going to be a route to the proxy. And this is obviously not a common setup, but there are environments where people don't want to configure the client stations with default routes. Like when you're dealing with some sort of high security environment where not having a default route on a client automatically means that it won't be possible for a potential malware, like a worm, to propagate further into the network. So like if you only use those clients, let's say to browse the internet, access web pages, you technically need just one IP route so the clients know how to get to the WSA. Default route is not needed. So just to recap on this design, like if we have a segment with our clients, this is going to be C1. I'm going to say that this is some sort of a network in the middle here, internal network, which is where we have the WSA. And let's say an edge device, like a backbone router, and then the internet with a web server. So again, no matter what URL the user enters on the C1's browser, the packet is going to be sent to the WSA. And now the WSA is going to take the packet, is going to perform several policy checks. It is going to perform name resolution to figure out what is the actual destination for, let's say, cisco.com, assuming that our web server is cisco.com. And it is going to resend the packet with its own source and the correct destination. So the original packet was, again, sourced by the client and destined to the proxy. And now WSA spoofs IP address. And what's actually funny here is that if you take a look at the proxies documentation, when they say that IP spoofing is disabled, they mean that WSA changes IP address inside of the original request. So in the proxies terminology, spoofing disabled means that IP address is changed, which is kind of like the opposite of most people assume when it comes to spoofing. But it is the way it is. And again, the WSA changes IP address and it sends the packet to the final destination. So this means that when the web server replies back, it replies to the proxy. So packet is now destined to the WSA. And WSA does the detranslation because it knows who the original request came from, assuming that the packet is allowed by the proxy scanning agents, and the reply is finally sent to the client. Okay, so two key takeaways. The resolution is performed on the proxy itself, and the only IP route that's needed on the client is a route to the WSA. Right, so what is now going to be different in case of a transparent mode? With transparent mode, the goal is going to be to redirect communication from the network to the proxy, which means that our clients are technically unaware of the existence of a WSA, and they work as usually, meaning that they will eventually perform a name resolution, and after DNS reply comes back, they are able to send the build a packet destined to the final web server in question. So in this case, it's going to be the network what intercepts web communication. There's going to be a redirection device. It could be a router, a switch, or ASA that is running WCCP, what eventually allows this device to take those web packets and then reroute them to the proxy. Like in the previous case, there are going to be a few things you have to think about when you deploy transparent mode WSA. First of those things is obviously the DNS resolution. And as I just said, the name resolution, the name lookups will be in this case performed by our clients because the clients are not aware of the WSA. Their browsers are not configured with any proxy settings. In order to build a web packet, they have to know layer 3 destination of the server. Okay, so this also means that our clients will now have to be configured with a default route. If there is more than one potential destination, it is not possible to add a static route for every single potential web server that the clients might want to reach. So web communication in general is going to fall back to the default route. Okay, so like in the previous case, I'm going to say that we will have a segment of our clients. C1, this is going to be our client. We have an internal network. We still have a proxy. I'm going to say over here. This is my edge device, like router 1. This is my internet. And I've got a web server over here. cisco.com, for instance. Right, so the communication starts once the user types in a URL in the C1's browser. In order to figure out the destination of our web server, C1 needs to perform name resolution. And once it learns about the destination, it is now able to send a packet with a source of C1, its own IP address, and the destination in question, www. So this technically goes in this direction, to the internal network and then to the edge router. But our router in this case is configured with WCCP. And it's going to be WCCP version 2, which causes this packet to be redirected to the proxy. So the WSA gets a packet with a source of our client. It inspects the packet and then again changes the source. It puts its own data port IP address and then forwards the packet to the final destination. Destination is already in the packet. WSA doesn't really have to perform the resolution. So the packet leaves through router 1 once again, gets to the server, and then we get a reply which is sent to the proxy based on the request source, and WSA does the inspection, the translation, and replies back to the client. Now in both cases, there is also going to be one additional thing that you will probably want to do with WSA in place. Like if this is going to be my internet cloud, so my network edge, in our case it was router 1, but maybe let's slightly change this design. Let's say that we have a firewall here on the edge, and this is our proxy. What you would also normally want to do, especially with transparent redirection, is that you would want to configure the firewall, its outside interface, outside access list, to only allow web communication from the proxy, versus all other web communication, so communication with any source, you would say you would want to block, not allow, just block. The reason you might want to do this is that only device that is allowed to reach web servers connected to the internet is going to be the proxy. Like if your clients were to somehow bypass the WSA, if this was explicit mode, maybe they modified the browser settings, or maybe transparent redirection is not properly working, you would want to use this config as an additional security measure, just to make sure that the only web traffic that can leave the network is the proxied sessions. As we just saw with transparent redirection, this deployment relies on a special protocol, a web cache communication protocol, WCCP, which is used to perform the redirection. WCCP was originally created for so-called content caching engines, content caching appliances, where the goal was to reduce congestion on low bandwidth WAN connections by caching certain content. In most cases it was web communication, but it could be also something else in web. Caching it locally on an appliance in order to deliver the information from the cache instead of allowing the original request to go out for the WAN connections. Of course, assuming that there is a matching content in the cache. Now, what we will use WCCP for is going to be to do the redirection from the network to the WSA. And the protocol relies on a concept of a service group, which is what eventually defines what packets we want to take from the network, from the interface where we enable WCCP, and redirect those packets to the WSA. And there are going to be two types of those service groups. We can go for a standard group, which is also known as web cache. This group is more of like a default, well-known description of the traffic that we want to intercept. And specifically, it is only TCP packets destined to port 80. So when you build a standard group, it means that you only want to redirect TCP communication destined to port 80. But how about if your web servers are listening on other ports? Or maybe you're using HTTPS. So in this case, you would have to build a dynamic group, which is where you will define characteristics of the traffic that you want to intercept and redirect to the proxy. So it can be something else than port 80. It could be 80, but it could be also something more, like 8080, like 443, anything else. You can also perform redirection based on the source port number. So dynamic group is going to be, in most cases, a way to go. And now, in order for the proxy and the redirection device to agree on what communication should be intercepted and sent to the WSA, the WCCP client, which is our WSA, and WCCP server, which is our redirection device, router, switch, or ASA, will have to agree on the WCCP service group settings. The entire process is known as WCCP registration, and it starts on the client. WSA is going to send here I am packet, which is a unicast or multicast destined to UDP port 2048. This packet is going to be intercepted by the WCCP server. The packet contains the service group the WSA wants to use. And now, assuming that our server is configured with a matching group, it is going to reply with an acknowledgement. It is going to be the WCCP ICU packet. So the point is that the devices will eventually agree on, well, of course, assuming that the configuration is correct, the devices will agree on the service group, and this way our router switch ASA will know what packets to send to the proxy. And in general, it must be version 2 of the protocol, what WSA supports. Even more accurately, for IP version 6, it must be version 2.01. So your router switch ASA must be running this version to talk to the WSA. And there are also going to be a couple platform-specific requirements, what you have to think about. Like if you want to use a switch to do the redirection, like if you're using 3560 devices, and those support WCCP, but only with the routing SDM template. So you would have to say SDM prefer routing, and only then you would be able to successfully configure a WCCP. Now, if you're using the ASA, the firewall only supports redirection through the same interface. So this is going to be an example of intra-interface communication, what is allowed with the ASA, like when our clients and the proxy are connected to the same port. For instance, if my ASA would be connected on the DMZ to the proxy, but my clients were connected to the inside, which is obviously a common setup, this is not going to work for WCCP. The only supported design is going to be when our WSA and clients are on the same zone. So I would put my WSA here, I would put my client over here, and let's say that this is going to be my inside. Because in this case, the redirection is going to be performed intra-interface, so on the inside and then back to the proxy. And this is going to work. One more thing I want to show you before we jump into a demonstration, the configuration syntax for iOS and then for the ASA. It is going to be actually very similar. On iOS, you will have to say IPWCCP, you specify the version, then you build a WCCP instance. Like when you say web cache, it means that you want to go for a standard group, versus when you specify a number like 90, 80, Anything between 1 and 100, I believe, is the range. It means that you want to use the dynamic service group. So in most cases, we will use a number here. And we have two additional options. Redirection list, this is how you will make exceptions to the communication that the device is supposed to intercept. Like I can say that packets from my admin subnet should be never redirected to the proxy. They should be allowed to go directly to the internet. And I can also use a group list, which is how you can specify what WSAs you want to use for a given instance. Because you can have multiple WSAs, and in general, you can load balance communication between those units. Okay, once we have an instance defined, we will have to activate it on an interface and specify a direction, inbound or outbound. Inbound direction is more preferred because it doesn't cause the device to process the packet and then send it back to the proxy. Like when the packet enters on the inside of the router in this case, and before it leaves via the outside, it's kind of like loop back via the outside, inside, then to the WSA. So this causes the router to process the packet. Versus when you do the redirection in the inbound direction, so over here, the device doesn't process the packet, it immediately sends it to the WSA. So this is more performance-friendly approach. On the SA, the syntax is going to be almost the same. We just skip the IP keyword. We simply say WCCP, build an instance, and attach it to an interface. The only direction supported on the firewall is inside. Right, so let's take a look at our network. I'm going to say that the goal is going to be to use the transparent redirection. So I want to use transparent mode on my WSA. My client is going to be located in VLAN 30, which is here, 172.16.3.0/24, where my proxy is located in VLAN 123, and the device that will do the redirection, it is going to be my ASA inside port. Right, what it means is that when my PC sends a packet, it is going to send it to one is going to send it to two will forward the packet to the ASA, and now the ASA is supposed to loop the packet, send it to two, and then two is supposed to forward it to the WSA. Then WSA is gonna spoof the source and send the packet to the final destination. Of course, the reply is gonna come back to the proxy, and then the proxy is gonna send it back to the client in this direction. So this is what we will try to accomplish in this session. Okay, for this to work, of course, we first thing have to define a WCCP instance on the firewall. I'm gonna say WCCP number 90. I will just hit the enter key. This is how I define an instance with no additional options. No authentication, no redirection lists, no group lists. And then I will say that I wanna use this instance on my inside in the inbound direction. The only supported direction for the firewall. Show run WCCP, really straightforward configuration. Then on the proxy itself, we will have to go to the first thing, security services and web proxy. I want to ensure that the web communication that I will want to redirect, which in our case is going to be port 80 traffic, I want to make sure that this port is enabled for the proxy on my WSA. Okay, so let's take a look at that. I just have to log in once again. We got a session timeout. Okay, go to the proxy settings. And this is pretty important. Some people actually forget about that. Remember that you may have multiple web servers in the network listening on different ports. If you want to proxy all this communication, the proxy must be configured with those port numbers. And by default, what we should see here is going to be these two ports, 80 and 3128. Also notice that the proxy mode is by default set to transparent. I'm actually going to edit those settings. So of course this is needed for the transparent mode. And this option actually, as we will see in just a second, it supports both types of traffic. It says when you use this option, the proxy is going to accept transparent and explicit forward connections. Versus when you say forward, it is only for explicit forward connections. So we want to use this option. Okay, we will need port 80, which is here. Spoofing is disabled, which means that we will change IP address to the WSA when we forward the connection. So I don't really have to change those settings. Now what we will have to do instead is that we will now have to define a WCCP instance and match our settings with the ASA. So we will go to Web Security Manager. No, it's gonna be under Network. It's gonna be under Network and Transparent Redirection. This is where I can define my WCCP instance. Okay, we will say add a device. And I'm gonna choose a WCCP version to router. So layer for switch, this is for switches. Router is for the ASA and for iOS. And we will now configure our service group. Once again, we take a look at the ASA. It is gonna be, hold on a second, instance number 19. What I wanna configure on the proxy. So this must match. We will say add service. I'm gonna call it ASA. This is just a name for the profile. And the number is gonna be 90. We will perform redirection based on the destination port. This is going to be for port 80 and also for port 443. Now, load balancing is going to be by default performed on the server address, which is not the best setting. Okay, so as I mentioned, it is possible to use multiple WSAs to serve web content. And the load balance option is to choose the proxy for communication. So when you say based on the server's address, it means that for packets sent to a single website, like for example Google, let's say that we will send packets to google.com. We will send those packets to just one WSA. Like we have multiple WSAs, WSA2, and WSA3. With this setting, all packets as sent to Google will end up on a single unit. In our case, it is WSA1. And of course, this is bad because in most environments, there are websites that are more frequently visited, much more frequently used than the other ones. And Google is going to be probably one of those examples. So in this case, if you have like 1,000 clients, all packets sent to Google will end up on a single WSA. Versus if you were to perform destination based on the client addresses, like we have 3 clients, no matter what is going to be the destination website, like Google or Cisco or something else, traffic is going to be balanced based on the sources and not based on the destinations. So no matter if client 1 wants to get to Google or Cisco, those packets will be physically sent to WSA1. Versus if the packets are sent from C2, they will end up on the, let's say, second WSA, and so on and so forth. So if you use multiple WSAs, this is going to be a much better option than to stick with the server's address. Okay, we have to tell it what's the IP address of our redirection device. In our case, it is ASA 192.168.21.10. I'm going to put it over here. And we will not use passwords. Advanced settings, this is how you can choose the balancing method. Do you allow for hashes or masks, or maybe one of the two? This stuff you can look up in the documentation, what it means, what's the difference. And the forwarding method is all about how do we exchange packets between the WSA and the redirection device. Like inside of GRE, tunnels, if our WSA and redirection device are in a separate network, or if they are in the same network, the best option is going to be to use layer 2 forwarding. If you leave those default settings, the device is going to automatically figure out the right option. I'm going to submit, and we will now have to push this configuration. Don't forget to commit the changes so they take effect. All right, put an optional comment, click on commit changes, and let's now take a look at it on the ASA. Before you start testing this in the data plane, it makes perfect sense to check your control plane first. And that is going to be the purpose of the show WCCP command, what you can use on the ASA, or show IPWCCP on an iOS device to get this information. So I'm going to say show WCCP. Let's just say show WCCP and hit the enter key. So it tells me what's the instance, what's the service identifier. And what we should also see here at some point is that it is going to tell us what's the proxy. Let's say show WCCP, let's say 90, and then take a look at the detail keyword. So it says this is IP address of the WSA, and notice that this was detected. I haven't configured it. And the state, this is the most important thing here, the state must be set to usable. It means that ASA can talk to the WSA and vice versa. And we can also take a look at the service option, show WCCP service, which is going to tell us about the service group. So we see that the ASA learned about the communication that is supposed to redirect, port 80 and 443. So if we know to test this in the data plane, I'm going to go to the PC, and we will try to connect to our web server. As I explained initially, the flow is supposed to be delivered to the ASA, and then ASA will loop this communication and send it to the proxy. This is what we expect to see here. And my test server can be reached by www.test.com. Maybe let's also say tail on the WSA. Well, let me reconnect to the proxy, to the command line, and we will take a look at logs in the real time to confirm that the transaction is in fact traversing for the proxy. And let's just send some packets. I'm gonna say tail, and I will choose number 1 for access logs. Okay, I'm gonna refresh this site. We see that we have connectivity. We just need to wait for a log message to show up. And it is here. It says that this is my client's IP address, my PC. Okay, this means that the website is not in the cache. You can look up the codes, the log codes in the end user guide. We send a GET request to our server, and then the website was categorized as part of the education. Its reputation is -3. We will talk about those settings in other sessions. What's important in our case is that this connection is in fact traversing through the WSA.